Okay, everyone. Hello. Hope everybody's doing well. Today I want to talk a little bit about chemical bonding. First of all, chemical bonds are attractions between atoms or groups of atoms. And there's a whole slew of them. Today I'm going to talk specifically about ionic bonding and covalent bonding. So I'm going to start with ionic bonding. So ionic bonds, these are attractions that are found between two oppositely charged ions. So cations and anions. Cations are positively charged ions, and anions are negatively charged ions. So quick review, ions are atoms with an overall charge, either a positive charge or a negative charge. Your cations are typically going to be metals, and your anions are going to be nonmetals. So that means cations are going to lose their valence electrons to have a positive charge to form cations, and nonmetals are going to gain valence electrons to have a negative charge. And the attraction between those oppositely charged ions form an ionic bond. So the attraction is formed by the transferring of electrons from one atom to another. So this is a perfect example. So just real quick here, I'm going to use lithium fluoride just as an example. So lithium, well, let's start here. Lithium has got 3 protons and 3 neutrons. I'm just going to write protons. And that means it is going to have 3 electrons. Now lithium has less than 5 valence, or I should say less than 3 valence electrons, so it will lose its 1 valence electron. So right now, lithium has got 3 positives and 3 negatives. But what's going to happen is it's going to lose a negative to end up having a positive charge. So let's talk about fluorine. So fluorine has got 9 protons, and so that means it's going to have 9 electrons. 1, 2, 3, 4, 5, 6, 7. So right now this fluorine, this is lithium. Right now this fluorine atom has 9 positives and 9 negatives. Well, to be stable, atoms want to have 8 valence electrons on that very last energy level. So what's going to make lithium happy is he is going to lose this 1 valence electron, and this fluorine atom is going to gain it. So I'm going to change colors. So this is our valence electron. Lithium is going to give up its valence electron and give it to fluorine. So when it does that, that makes lithium have a positive 1 charge to it. Because if you lose, okay, whoops, let me try that again. If you lose a negative charge, this guy is negatively charged and he's going to come over here, okay? We now have 2 negative charges and an extra positive. So lithium is going to become a cation, while fluorine is going to gain that valence electron, and now it has 10 negative charges. So fluorine is going to end up with a negative, what we call oxidation number, or negative charge. So the attraction between this positive and this negative forms right here what we call an ionic bond. So I'm going to go back here. So the attraction is formed by the transferring of electrons from one atom to another. Usually, not usually, but when we're talking about formulas that represent substances that have ionic bonding, the metal is always going to be in the front and the nonmetal is always going to be in the back. So the cation will be in the front, the anion is going to be in the back. So anytime you have a substance that has ionic bonds, we will call it an ionic compound. So when it comes to ions, okay, or I should say when it comes to ionic compounds, like I said, when an ionic compound forms, and ionic bonds are formed. Metals are usually going to form bonds with nonmetals. Okay, so anything in the green area, those are all metals. All of these guys will form cations. They're all going to lose their valence electrons to the guys in the blue. All the guys in the blue, okay, they are considered to be nonmetals. These guys here, right here, they're metalloids. A lot of times metalloids are going to bond with the nonmetals. So when it comes to ionic compounds, you're usually going to have metal elements, okay, losing their electrons to non-metallic elements. So what's super, super popular, sodium loses its one valence electron to chlorine, so they form an ionic compound called sodium chloride, which we would put on our food. That's salt. So it's the transferring of electrons. So when it comes to ionic bonding, okay, again, it's the formation of a bond between ions. We can have, there's a whole slew of different types of ions that are present. Monoatomic ions, mono means one. These are ions, okay, with one atom present. So all of these are examples. Calcium, okay, is a +2 ion. Potassium is a +1 ion. Chlorine is a -1 ion. Phosphorus is a -3. So monoatomic ions are ions with one atom present. Okay. We also have ions that are called polyatomic ions. So poly means many or multiple. So polyatomic ions are groups of atoms that are held together with covalent bonds. We'll talk about that in a second, but they have an overall charge. So if I was to take let's take sulfate, SO4, 2-. So the sulfur is bonded to the oxygen, okay, with covalent bonds, but somewhere in this group of atoms we have 2 extra electrons. So since this group of atoms has got 2 extra electrons, it is considered to be an ion. So what would happen was this group of atoms, which is a polyatomic ion, we call it sulfate, okay, would want to gain 2 electrons, okay, to become stable. So they want to gain 2 electrons, or he would gain 2 electrons to make a stable compound. So for instance, magnesium has a +2 charge, sulfate has a -2 charge. So when magnesium loses its 2 valence electron, this guy is going to gain them. So there's this attraction right here between this monoatomic ion and this polyatomic ion, and this is an ionic bond. Okay, so when I had this example here, this is magnesium and this is nitrate. So this is an ionic compound. Our ionic bond comes between the magnesium and the nitrate. Here, our ionic bond comes between the calcium and the chlorine, and here, the bond is between the lithium and the bromine. Since these all have ionic bonds, they're called ionic compounds. Okay, so our next type of bond is a covalent bond. So covalent bonds are attractions between atoms that share 2 or more valence electrons. Or let me start over. The attraction that is formed between 2 or more atoms when they share valence electrons. So covalent bonds are going to form between nonmetallic elements and possibly even metalloids. So you're going to have a lot of these elements right here in the blue and hydrogen bonding with one another, and when they bond with one another, they're going to form covalent bonds. Also, same thing like silicon and oxygen bond together, and they would have covalent bonds. They would share valence electrons. The closer the atoms are to one another, the more covalent the bond is going to be. Okay, So a covalent bond is formed when non-metallic elements or metalloids share valence electrons. So they're going to share them. So that means the shared valence electrons are going to spend some time in one of the atom's electron cloud and some time in the other electron cloud. And that movement of the electrons from one side to another, one electron cloud to the other, is going to form an attraction between those elements. Okay? A lot of times, if elements have got covalent bonds, we call them molecular compounds. Sometimes we even call them molecules. Now, you know that a substance, when you look at the chemical formula, you know a substance has got covalent bonds because if you look at the substance or the elements, you're going to have, if you have two nonmetals, you know there's covalent bonds. Two nonmetals, covalent bonds. Or, like I said, a metalloid and a nonmetal, there'll be covalent bonds. Same thing here. Okay? There's two types of covalent bonds. So there's two ways atoms can share electrons. And the way they share electrons determines the type of covalent bond. So we have polar covalent bonds and nonpolar covalent bonds. So I'm going to start with polar covalent bonds. So polar covalent bonds are when electrons are shared between different atoms unequally. So this kind of shows an electron cloud density, okay, between two atoms. So this negative side right here means that the shared pair of electrons, so let's say we have, I'm going to change my color here. So let's say we have our shared pair of electrons. These two electrons would spend some time around this electron cloud, and they're also going to spend some time around this electron cloud. The thing is this atom is stronger, so these two electrons are going to spend more time in this cloud, making it bigger, making this atom just a little bit negative, making this cloud smaller because the electrons aren't spending as much time there. So this makes this side just a little bit positive. So when you have atoms, when one atom is stronger than the other, when they're sharing valence electrons, okay, they're going to form a polar covalent bond. Electrons are shared unequally. So my example, it says, like a tug of war that is being won by one atom. The atom with the stronger pull on the shared electrons wins the tug of war, and the electrons spend more time in that electron cloud. This unequal sharing results in oppositely charged ends in a molecule that has a polar covalent bonds. So a lot of times we will say, like water, we say is a polar molecule because it has polar covalent bonds. One end is partially positive and the other end is partially negative. So this sign means partial. This sign means partial. Partially negative, partially positive. The partially negative side means the electrons are going to spend more time in that atom's electron cloud. They'll just like spin around here and spin around here, but they're just going to spend a lot of time in the atom's electron cloud that is stronger. A lot of times we say they have a higher electronegativity. Now water, this guy is literally like the most polar molecule ever. So polar molecules, or I should say water being a polar molecule, gets so many of its properties just by being polar. So the partially positive side and the partially negative side really dictates water being like the universal solvent. It dissolves most things. It has a high surface tension. That means when water molecules bond together, they are very, very, very strong, and they form like almost a very, very strong force, and very small light things can actually like rest on top of water because the positive and the negative attraction between water molecules is really strong. So if we are looking at a water molecule, the oxygen would have the negative, partially negative side. So oxygen is going to be much stronger than my two hydrogen atoms. So we would have a shared pair of electrons here and a shared pair of electrons here. These two electrons are going to spend time in this hydrogen cloud and then in this oxygen. And then we would have another shared pair of electrons. This line represents a shared pair, but I'm just going to put dots. So these two electrons are going to spend time in hydrogen's cloud and also oxygen's cloud. But oxygen is so much stronger, these two electrons and these two electrons are going to spend more time in the oxygen cloud, making it a little bit negative because electrons are negative, less time in the hydrogen cloud, making these guys positive. So this is what happens quite often. If you get a whole bunch of water together, hydrogen is partially positive, oxygen is partially negative. H2O, partially negative. What happens is when you get water, a bunch of, beaker full of water, the negative side of this molecule and the positive side of this molecule, they're attracted to one another, and that's actually called a hydrogen bond. And like I said, this polarity of the water molecule gives water a lot of its properties. Like water has what we call a very high specific heat because of this attraction. It can take in a whole lot of heat energy before the temperature goes up. Okay, so the next type of covalent bonding is called nonpolar covalent bonds. And this is the sharing of valence electrons between atoms, okay? Two different or two, as in not different atoms, as in they have to be different elements, but two different atoms, like two individual atoms. So when electrons are shared equally. So as you can see down here, this shows two atoms, and you can see that the density of the clouds are equal. And that means the electron is going to spend our shared pair of electrons right here. These two electrons are going to spend equal amount of time in each electron cloud. So that density cloud is the same on both sides. Usually nonpolar covalent bonding occurs between atoms of the same type of element. So two chlorine atoms, that means that chlorine is going to have the same pull on these two electrons, and so you don't have any polarity. Neither atom has a stronger pull on the electron, so they are pulling equally hard. Now these videos I have embedded, we'll watch those in a second. Some characteristics of covalent molecules and ionic compounds. So covalent molecules are substances that have covalent bonds, and of course ionic compounds are substances that would have ionic bonds. So ionic compounds have a crystal lattice structure, as in they've got this sort of very rigid, tight, geometric pattern, and the atoms are held very tight together. They have very high melting and boiling points. It takes a lot of heat energy to break the bonds between like your metal and your non-metal. To break this bond is going to be very, very hard because you have a very structured repeating pattern of cations and anions, and it's a very strong bond. So strong bond between units, conductivity, conduct electricity when melted. So if I was to take sodium chloride and if I was to melt it down, which would take a lot of heat energy, it could actually conduct electricity. Ionic compounds dissolve in water, and then they also conduct electricity when dissolved. Covalent molecules are typically gases, liquids, sometimes solids, but often very soft solids. They have very low melting and boiling points. That means that the bonds that hold covalent molecules together are not as strong, and it makes those substances gases and liquids or soft solids. Or could be very brittle solids. Weaker bonds between the molecules. And of course, if we break them down, polar covalent molecules, that means they have electrons that are shared unequally. They are poor electrical conductors. And then nonpolar covalent bonds don't conduct electricity at all. And only the polar molecules dissolve in water. Okay, that's it. I hope that makes things a little more clear, and I hope everybody is doing well. Have a wonderful, wonderful day.